Good day everyone. So, pupunta na tayo ngayon sa applications ng mga natutunan natin with regards to our derivatives and also the implicit differentiation. So, saan ba natin pwedeng magamit ang mga derivatives? Okay, so for our learning competencies, first, the learner solves problems, including logarithmic and inverse trigonometric function, using implicit differentiation, and also the learner solves problems involving related rates. Okay. So first, yan, magre-recall muna tayo ng ating natutunan with regards to our derivatives and implicit differentiation. So we have here our guide questions. Okay, first, what methods? So here's the first item, which is y is equal to logarithm of x cubed plus 2x minus 2, okay, with our base 2. Okay, so recall tayo, pag nagde-differentiate tayo or derivative, kumukuha ng derivative ng logarithm. Okay, for example, with the base e, that is the ln. Okay, ang base niya ay e. Walang yan sa logarithm with the base e. Okay? Kapag ganyan, okay, ln of x, okay, pag kinukuha natin yung derivative nitong ln x, okay, that is simply 1 over x. So parang mapupunta sa denominator yung kasama ng ating logarithm. Okay? Or ni ln. Pero kapag iba yung base, we have the base 2 here. Okay? Madadagdagan lang yung ln x natin. Okay, parang nagde-derive lang tayo ng ln x. So y prime, that is equal to, okay, 1 over the natural logarithm of our base, okay, which is 2, multiply to, okay, parang nagde-derive ng ln. So 1 over x cubed plus 2x minus 2. Okay, multiply natin dun sa derivative ng nasa loob. Okay, so we have 3x. Okay, derivative pa nung kasama ng ating logarithm nasa loob. So x cubed plus 2x minus 2, ang derivative niya ay, if first term is 3x squared, bumaba yung exponent na minusan ng 1 plus 2. Okay, and that's it. So we have our answer. Is just simplify or ayusin lang natin. And we have 3x squared plus 2 over x cubed plus 2x minus 2 multiplied to ln of 2 or natural logarithm of 2. So number 2, we have the ln of x plus sine x. So, okay, sir, may cube dun sa ln. So, ang meaning din yan, so parehas lang din yan sa ln of x plus sine x. Okay, naka-raise sa exponent yung buong function natin. So, ln x plus sine x raised to 3. Okay, so meron tayo exponent involved. Okay, pag kumukuha tayo ng derivative tapos may exponent, so involved lagi ang power rule. Okay, so for our y prime, we have power rule, bababa sa exponent, copy yung buong function na naka-raise sa exponent. So ln of x plus sine x. Okay, tapos naka-raise sa 2. Kasi na-minusan na ng isa yung exponent. Okay? So, hindi pa tayo tapos. Power rule, yung nasa loob ng naka-raise, which is the ln of x plus sine x. So, meron pa yang derivative. So, ide-derive pa natin yan. Okay. Anong derivative ng ln x plus sin x? Okay. So, we have 1 over x plus sin x. Okay. So, itong kasama ni ln, which is x plus sin x naman, is meron pang derivative yan. So, we have the derivative of x plus sin x is 1 plus cosine of x. Okay, so what we have done here is what we call the chain rule. Okay, so parang papaloob tayo ng papaloob hanggang wala na tayong makukuha na derivative. Okay, so this is our final answer. Yan, inayos lang natin. So 3 multiply to ln squared of x plus sin x multiply to 1 plus cosine x over x plus sin x. For our last item, we have x squared y plus 2y cubed is equal to 3x plus 2y. So, kung mapapansin natin, yung sa dalawang item natin, ayan, so nakahiwalay si y. Okay, so this is what we call the explicit function. Okay, and nag-derive tayo directly. So, on the other hand, para sa pangatlong item natin, we have x squared y plus 2y cubed is equal to 3x plus 2y. Okay? So, ang gagawin natin dito ay implicit differentiation. Since hindi nakahiwalay si y sa other variable. Okay? So, we will be differentiating this with respect to x directly. Okay? So, hindi na natin siya gagalawin. For our first term, we have x squared y. So, differentiate natin with respect to x. We have x squared y. Okay? So, product rule, derivative ng una. Okay? Sorry, copy the first and then derivative ng katabi plus copy the second derivative naman ng una. Okay? So, that's how we do the power rule. So, x squared multiply to the derivative of y with respect to x is 1 dy over dx. Plus, copy naman yung y, derivative naman ni x squared. So, that is 2x. So, this is for our first term. Dito naman tayo sa second term. Derivative ni 2y raised to 3 is 6y squared. Okay? So, we are deriving with respect to x. So, we have the variable y. So, magkakaroon lang siya ng dy over dx is equal to derivative ni 3x is 3 plus derivative ni 2y is 2 with respect to x yan, 2 dy over dx. Okay? So, we have here, ayan, simplify natin, x squared dy over dx plus 2xy plus 6y squared dy over dx is equal to 3 plus 2 dy over dx. Okay? So, pagsasama-samahin lang natin. So, what we need here is the dy over dx. Since yun yung hinahanap, yun yung derivative. Okay? dy over dx equal din yan sa y prime. Okay? So, hiwalayin natin si dy over dx. Lahat ng term na may dy over dx ay pagsasamahin natin. So, x squared dy over dx. Tapos ito plus 6y squared dy over dx. Tapos nasa kabilang side na equation natin yung 2 dy over dx. Pag nilipat natin katabi ay magiging minus. So, minus 2 dy over dx is equal to 3. Okay? Minus 2xy. Ilipat natin si 2xy sa kabilang side ng equation dahil wala siyang dy over over dx na kasama. So, 3 minus 2xy. Okay, so napagsama-sama na natin lahat ng may dy over dx. Okay, so ifa-factor out lang natin siya. So, dy over dx, factor out ko. Ang matitira per term ay x squared plus 6y squared minus 2 is equal to 3 minus 2xy. Okay, bring down, okay, divide both sides by x squared plus 6y squared minus 2. Okay, ang matitira sa atin ay dy over dx is equal to 3 minus 2xy divided by x squared plus 6y squared minus 2. So, that is implicit differentiation. So, we get the derivative of our equation through implicit differentiation, and kung mapapansin natin, merong y variable. Okay? So let us answer the guide questions. What methods did you use to obtain the derivative? So dun sa first two natin, okay, direct differentiation. So that is explicit. So nakahiwalay si y. So on the other hand, sa ating third item, we have the implicit differentiation. So number two, what kind of functions did you encounter in the given? Okay, so again, meron tayo kanina. So sa number 1 and 2, we have the logarithmic function. Kasama yun yung ln, and also yung trigonometric function. So number 3, how did you determine the derivatives of the given? Okay, so by applying the the rules in differentiation. Okay, so let's move to our lesson proper for this week. So we can implicitly differentiate a function with respect to another variable. So for example, time. Okay, so kung kanina nag-differentiate tayo with respect to x, di ba? Kapag nagdi-differentiate tayo ng with respect to x, okay, for example, x squared. So differentiate natin with respect to x. Okay? That is 2x lang. So, hindi na natin lalagyan ng dx over dx since ma-cancel lang din yan. So, whereas kapag nagdi-differentiate tayo with respect to x ng ibang variable, for example, y squared, we have the 2y, kailangan pa nating lagyan ng dy over dx. Since, again, we are getting the derivative with respect to x, but iba yung variable niya. Okay? So dy over dx is defined as the rate of change of y with respect to x. Okay? So that is the instantaneous change in y with respect to x. So we have here, for example, we will be differentiating a function with respect to another variable naman, with that is the time. Okay? So dt ang isusulat natin. Okay, so for example, meron tayong circle that is expanding its area. Okay, so as time passes by, dumalaki yung ating circle. Okay, so may involved na another variable, which is again the time. Okay, we can notice that all the parameters of the circle, including its radius, yun yung radius niya. Okay, as the area increases, the radius also increases. So we have our formula for the area of the circle, which is the A is equal to pi r squared. If we take the derivative of that, we have derivative with respect to time. We have dA over dt is equal to, okay, pi, ilalabas natin yung pi since constant yan. So, si r squared na lang. So, derivative with respect to time of r squared, that is, bababa yung exponent, we have 2r, okay, dr over dt. Okay, so kung mapapansin natin, we have dA over dt and dr over dt. So, anong ibig sabihin nun? Okay, dA over dt is the rate of change of area with respect to time. Okay, kung gaano kabilis nagbabago yung area, okay, kasabay ng time. So we have also the dr over dt, which is the rate of change of the radius of with respect to time also. Okay, so nagkaroon tayo ng bagong variables. Okay? So, nung dinerive natin with respect to time, yung formula ng ating circle, ng area of the circle, which is A is equal to pi r squared. Okay, so, mamaya magagamit natin yung differentiation with respect to another variable pag napunta na tayo dun sa problems natin with regards to the related rates. So for our discussion, we have the derivative of a function is its instantaneous rate, okay, rate of change with respect to the variable. So kanina, with respect to time, okay, that is the instantaneous rate of change of the, for example, dA over dt. Okay, yung area yung nagbabago with respect to time. Okay, that is the rate of change with respect to time. So time rate of change is interpreted as the velocity when a function describes either position or distance. Okay, so this is why derivative can be used in the application of related rates. Okay, for example, meron daw tayong function f of x equal to x squared, tapos that is the position or distance of a certain point. Okay? Pag kinuha natin yung derivative niyan with respect to time, okay? So f prime of x, we have 2x. Okay? That is now the velocity. Okay? Ayan. So here are some of the examples of the application of our derivatives. So first, ayan, we have here the calculate calculation of related rates by implicit differentiation. So gumagalaw yung hagdan, okay? Pwedeng pababa daw, okay? Unti-unting nalalaglag yung hagdan. Also, we have here the airplane. Tapos for example, nandito ka sa position na to. Okay, so nagbabago yung angle theta. We have here the inverted cone problem, which involves water na inilalagay natin sa ating inverted cone. Okay? So as time goes by, umaangat yung water. Okay? So pwedeng ang computin dito ay rate of change ng pag-angat ng tubig. Okay? All right. So now we will move to the solving problems related to differentiation. So these steps can be used. So number one, ano nga ba yung mga steps para madali nating masolve yung mga problems with regards to the application of our derivative. So number one, analyze the problem and determine the given and what is required. So given and what is asked. Number two is sketch the figure describes in the problem. Okay? So dapat pwede rin nating sketch or i-drawing yung sinasabi sa problem para mas madali nating maintindihan. Next, we have label all quantities with symbols. Okay, so pwede natin siyang lagyan ng certain variable x and y para madali rin nating um, ma-derive or malaman which is which. So number 4, set up an equation that relates the variables. So number 5, analyze how will the problem be solved using the derivatives. Okay. So without further ado, let us have the first example. So application on logarithmic function. Problem number 1, determine the equation of the tangent line. Equation of the tangent line parallel to the line 2xy plus 3 is equal to 0 for the curve y is equal to 5 ln x. So this is the curve 5 ln x. So y is equal to 5 ln x. Okay. So and we have a line here. Okay. So sabi, determine the equation of the tangent line daw parallel to the line 2x minus y plus 3. So ito yung line na yon. Okay. So we have another line. We will be creating another line na parallel daw dyan. Okay? Tapos, tangent sa ating function. So, ito po yan. Okay? So, that is the tangent line. Okay? So, ano daw ba yung equation ng line na yan? So, parallel daw siya dito sa line na given 2x minus y plus 3 is equal to 0. Tapos tangent sa y is equal to 5 ln x. So, paano natin kukuhanin yon? Kung maaalala natin, okay, so we have our slope of our tangent line. So, we have the slope of tangent line which is the dy over dx as well. So, we have to derive our function. Okay, so to get the slope of tangent line, we have to derive to get dy over dx. So we have y is equal to 5 ln x. Getting the dy over dx, okay, we have to derive. So 5 ln x, so ilalabas lang natin yung 5 which the constant, multiply to the derivative ni ln x which is 1 over x. So we got d dy over dx equal to 5 over x. Okay? So, yun na yung slope ng ating tangent line. Okay? So, slope of our tangent line, 5 over x. Okay? So, sa given natin, we have another line here. 2x minus y plus 3 is equal to 0. So, i-transform natin siya sa point slope form. So, we have here the 2x plus y, 2x minus y, plus 3 is equal to 0. So, transform natin 2x plus 3 is equal to y. Okay? So, pagbaliktarin lang natin, y is equal to 2x plus 3. Okay. So, na-transform natin siya sa point slope form. So, ang slope natin is yung kasama ni x. Okay? Tapos ito, di ba, yung y-intercept. So, si 2, yung kanyang slope. So, pwede nating i-equate dun sa ating slope ng tangent line which is 5x. Since parallel daw. Kapag parallel, same slope. Okay? Kaya, i-equate ko kay 2 yung ating slope ng tangent line. So, slope ng tangent line is 5 over x. Equal din yan sa 2. So, 5 over x is equal to 2. Okay? We will get, so 5 is equal to 2x. Pwede na nating makuha si x, which is 5 all over 2. Okay? So, meron na akong x is equal to 5 over 2. And then, kailangan na lang natin si y. Okay, so meron na tayong slope. So dito ko sulat. So slope natin is 2. Then si x value is, or yung abscissa, kailangan na lang natin si y. So saan natin kukunin si y? Dito sa function natin. Okay, y is equal to 5 ln x. So y is equal to 5 ln of what is x? That is 5 over 2. 5 ln of 5 over 2 yung ating y. Okay? So, nung nakuha na natin lahat ng mga yan, so we got the slope of the tangent line, which is 2. So, meron tayong nakuhang x, which is 5 over 2. And also the y, 5 ln of 5 over 2. So, saan natin gagamitin yan? Sa point slope form to make the equation of the tangent line. Point slope form. So, point slope form is y minus y sub 1 is equal to the slope multiplied to x minus x sub 1. So we have y minus 5 ln of 5 over 2 is equal to the slope, which is 2 multiplied to x minus 5 over 2. Okay, so you just have to simplify. So y minus 5 ln of 5 over 2 is equal to 2x minus 5. Y is equal to 2x minus 5 plus 5 ln of 5 over 2. Okay, and that will be the equation of the tangent line as our final answer. So, yun yung tinatanong and we got our answer. Okay? Okay, so if we are going to graph, so here is our solution. Okay, so ito yung tangent line and we have dy is equal to 5 ln of x na curve. All right, so we have the y is equal to 5 ln x na curve. So i-graph natin yung equation ng tangent line natin. Okay? So here we can see that we have the curve and the tangent line to our curve. Okay? So this is just to check if yung na-create nating equation ay tangent niya to a 1 point sa ating curve. Okay? So let us now have our second problem. Okay? So, application na to on related rates. So, magkakaroon na tayo dito ng differentiation with respect to time. Okay? So, nagkaroon tayo ng another variable since, ayan. So, we have here the problem number 2. An air balloon is pumped into a spherical balloon okay, at a rate of 10 cubic feet per minute. At what rate is the radius changing when the radius is 4 feet? All right, so we have the equation daw ng ating, okay, so ang given natin, analyze muna natin. We have the radius 4 feet. Okay. Yung spherical balloon ay lumalaki daw. For example, we have the balloon. Yan, spherical yan. So imagine natin, perfect sphere yung ating balloon. So lumalaki yung balloon natin at a rate of 10 cubic feet. 10 cubic feet per minute. Itong cubic feet na to is, okay, ang dinedefine niya ay ang volume. Okay? So, nag-change yung volume with respect to time. So, per minute, lumalaki ng 10 cubic feet. And that is, we have our dV over dt. Again, derivative is defined as the instantaneous rate with respect to another variable. So this dV over dt is the rate of change of the volume with respect to time. So we have 10 cubic feet per minute. Okay? So ang hinahanap, at what rate is the radius changing when the radius is 4 feet? So yung radius then, of course, as the volume increases, the radius also increases. Okay, so the radius dr over dt. So yun yung hinahanap. Nung dumating na sa 4 feet yung kanyang radius. Okay? So we have here the volume na involved. So, bubuuin natin yung equation ng ating volume. So, the volume for our sphere is 4/3 pi r cubed. We have the constant 4/3 pi. Okay. So, if we get the dV over dt, okay, derivative using the implicit differentiation, okay, implicit, direct yan. I mean, hindi natin babaguhin yung ating pinaka-equation. So we have derivative ni V with respect to T is dV over dt. That is equal to derivative ng 4/3 pi r cube. Just copy the constant. Okay. Multiply to 3r squared. Okay. Since r yan, we are getting the derivative with respect to time. So, dr over dt. Okay? So, meron tayong involved na dv over dt. So, given yan, pwede natin i-substitute mamaya. We have the r, radius. We have the dr over dt. So, lahat ng kakailanganin natin ay given na po. So, dr over dt yung hinahanap natin. So, let's try to substitute our given to the derivative. Okay, so dv over dt, that is 10 is equal to 4/3 pi cubic feet per minute. 4/3 pi multiplied to 3 times. Okay, pwede na natin i-cancel si 3 here. So multiply to r squared. What is r? That is 4. So 4 squared multiply to the dr over dt, which is what we will be solving. Okay, so 10 is equal to 4 pi multiplied to 16 dr over dt. Ayusin natin yung ating equation. para ang matira ay dr over dt. Okay, lipat ko lang dito. Dr over dt is equal to 10. Okay, so yung kasama ni dr over dt of course is bababa sa denominator. So 4 pi over 16. Okay, so guys, din-divide lang sa 4 pi over 16. 4 pi times 16. Okay, so we have dr over dt is equal to 10 over 4 pi times 16. Okay, so dr over dt is equal to 10 over 64 cubic or feet per minute. Okay, and that will be our final answer. Okay, so sa ating problem, as the volume increases at a rate of 10 cubic feet per minute, okay, so the radius is changing at a rate of 10 over 64 pi feet per minute. Okay, nung ang radius na ng ating circuit or spherical balloon ay 4 feet. Okay, so another example, we have the viral breakup problem on related rates also. Okay, so maybe yung iba sa inyo ay nabasa na itong problem na to, okay, sa Facebook or any other social media platform. So here we have the problem number 3. On a rainy day, a girl broke up with her boyfriend after being together for 8 long years. They decided to separate at the place where everything about them began at the same time. For example, here so dito sa point na to, nagsimula yung girl and yung kanyang boyfriend. Okay, so for example, we have their point. Yan yung point kung saan sila, ayan, nag-uusap pa lang. Okay, so nung nag-decide silang mag-break, sabi dito, the boy is due north, crying, and running at the rate of 5 feet per second. So yung lalaki daw ay tumakbo sa direction na to. Okay, pa-north daw at a rate of 5 feet per second. Okay, so pwede nating iset to since pa-vertical yan as y. Okay, so yung kay boy. And then dun sa girl naman, we have the girl is walking due east at the rate of 1 foot per second. Okay. So, kunwari, ayan, si yung girl, naglalakad lang daw siya at a rate of 1 foot per second. So, we can set as x yan, si girl, okay, since siya yung naka-horizontal. Okay, so thinking if she made the right decision. So, how fast are they separating from each other 5 seconds after they started moving to a new life without each other? Okay. So, sabi ito, yung separation nila, Okay, of course, iyan, habang si lalaki ay um, papunta sa north, okay, habang lumalayo siya, okay, and also si X or si girl ay naglalakad din pa east. Of course, yung separation nila ay also nagbabago. Okay? So this separation distance is also changing. Okay? So we have here dy and cx. Okay? And here, as we can notice, we have here the right triangle. Okay? So pwede nating iset itong separation nila as S. Okay? The separation distance. So as we can imagine again, habang lumalayo sila sa isa't isa, okay, si Y ay straight up lang or straight north, si X ay straight to the right lamang. Okay? So we can define the Pythagorean theorem. So we have here the x squared plus y squared is equal to s squared. Okay? So ito, 5 feet per second niya is the dy over dt. And ito namang 1 foot per second ni girl ay the dx over dt. Okay? So nagbabago yung x with respect to time at 1 foot per second. Ito naman si y ay nagbabago with respect to time 5 feet per second. Okay. So we get the derivative of this with respect to time. D over dt. Okay. So the first term 2x, okay, x squared is the derivative niyan with respect to time is 2x of 2 dx over dt. Since we are deriving with respect to time, lagi pong may kasamang d over dt plus 2y dy over dt is equal to 2s ds over dt. All right. So we have x dx over dt plus 2y dy over dt is equal to 2s ds over dt. So given ba tayo ng x and y? Okay. So sabi dito 5 seconds after they started moving. So dun natin kukunin si x and y. Kay x, after 5 seconds, ilang feet na yung na? So andito na si girl. So after 5 seconds, nakatravel na siya ng 5 feet. Si boy naman, 5 feet per second. After 5 seconds, nakatravel na siya ng, okay, for example, nandito siya. Nakatravel na siya ng 25 feet. Okay? So that is our x is equal to 5 and si y is equal to 25. Okay? So we have our given, all our given. Ang hinahanap sa atin as is the how fast are they separating from each other? So this is the rate of change of the separation with respect to time. So ds over dt. Ito po yung hinahanap sa ating problem. ds over dt. So substitute lang natin yung lahat ng ating given. So 2 multiply to x which is 5. Dx over dt is the rate of change of the yung sa girl which is 1 plus 2 times the y which is 25 multiply to dy over dt, rate of change of the boy due north. So that is 5 is equal to 2. Okay. Yung s natin, okay, since we have defined the point after 5 seconds of the boy and the girl. So we have here the 5 and 25. Okay? So, yung separation nila at that certain time is square root of 25 squared plus 5 squared. So, kunin natin si square root of 25 squared plus 5 squared. That is 25.5 na lang. So, S is equal to 25.5. Okay? 2 multiply to 25.5 ds over dt. Okay? So, burahin ko muna yung ibang given. All right, so we just have to simplify our equation. So 2 times 5 times 1 is 10 plus 2 times 25 times 5 is 250 plus 250 is equal to 2 times 25.5 is 51 ds over dt. Okay, so simplify 260 is equal to 51 ds over dt. So multiply both sides by 51. Okay, so pagpalitin ko lang. So 51 ds over dt is equal to 260 para mas madaling makita natin si variable. So 51 ds over dt is equal to 260. Divide both sides by 51. So we get ds over dt which is equal to 260 over 51. So we have our final answer. 260 of divided by 51. So 5.098. So the answer is 5.098 feet per second. Okay? So habang nag-change yung ating y and x, okay, habang sila ay naglalakad, yung separation nila ay nag-change 5.098 feet per second. Okay, so yun yung rate ng separation. Okay, so for our solution, okay, ayan, nilagay ko rin po dyan. And we have solved the viral breakup problem with regards to related rates. Okay, and that's it for our application of the derivative and implicit differentiation. Okay, thank you very much for listening.